Advanced Math, Lesson 18, Advanced Word Problems. So these are going to actually be pretty fun. They might be a little bit of a headache at first, but once you start getting better at them, you'll enjoy them. And this lesson may be 2 videos because there's a few things to go over, and word problems take about 4 to 5 minutes a piece. So let's start with the first form of advanced word problem. The first form of advanced word problem is we're just going to have 3 variables with 3 equations. The first example, and this can be seen in our nickel and dime problems, which originally we only have nickels and dimes. Right now we'll be having problems with nickels, dimes, and pennies, or nickels, quarters, and dimes. And there'll be 3 unknowns instead of just 2. The first example goes in terms of color. So they tell us the number of blues was 4 less than the sum of whites and greens. Also, the number of greens equaled the sum of blues and whites. How many of each were there if there were twice as many blues as whites? Now, another key thing is a lot of times in these problems there will be 3 equations instead of 2. The first equation we spot the number of blues was 4 less than the sum of whites and greens. So we can write that as number of blues was 4 less. It means we're going to have minus 4 at the end. The sum of number of whites plus number of greens. That's equation number 1. Going back to the problem, they say also the number of greens equaled the sum of the blues and the whites. So that's a pretty simple equation. I just put number of greens equals number of blue plus number of white. So n sub g equals n sub b plus n sub w. Cool. Equation number 2. Now, where is equation number 3? It's right after the question. They say how many of each were there if there were twice as many blues as whites. That's an equation in itself. Twice as many blues as whites. So let's put this down. Twice as many blues as whites. The way I like to do these is I like to set them equal because we know that's not true. If I say number of blues equals number of whites, that's not true. There's twice as many of these. So how do I make whites equal to the bigger number? I multiply it by 2. All right, that helps me avoid some errors because a lot of times when you read twice as many blues as whites, you want to write 2 times number of blues equals number of whites. And that would not be true because this is the bigger value. It's twice as many of these as these, so we got to double the smaller one. From here, I'm just going to go into substitution. One of my equations is really simple. It's already solved for n sub b. I can substitute n sub b with n sub w. So I'm going to do that. And this, doing both of our equations. Yeah. So this top one will replace that with 2n sub w. We got to fix our focus. Hold on. That's better. So we have 2n sub w equals n sub w plus n sub g minus 4. So that's that substitution right there. And then we'll substitute this right here. So we get n sub g equals 2 times n sub w plus n sub w. Hey, I've got like terms right here. I can go ahead and combine these. So then what I have is n sub g is actually equal to 3 n sub w. Normally I try to go for elimination after substituting once, but this equation is going to work out for me very nicely. I can just go straight into substitution again. I can substitute ng with nw. So I'll rewrite this top equation again. We got 2n sub w equals n sub w plus 3n sub w instead of n sub g. And then minus 4. Again, I've got like terms. I can combine these. That becomes 4n sub w. From here, I'll go ahead and I'll subtract 4n sub w from each side. That's going to cancel. I get negative 2n sub w equals negative 4. From here, I divide each side by negative 2. Cancel the negatives, cancel the 2's, cancel the negatives, and 4 divided by 2 is 2. So n sub w equals whole number 2. All right, and then I'm going to take this value, I'll just plug it into here and here. So starting with n sub g, so n sub g is just going to equal 3 times 2 now. Well, 3 times 2 is 6, so n sub g equals 6. And then here, NB, that's just going to be 2 times 2 now. So NB equals 4. So I know there's 2 whites, 6 greens, 4 blues. So that's our first taste of advanced word problems. And then we'll see 3 unknown problems with our nickel and dime problems as well. So that's our first type. The second type is going to be a ratio type of word problem. And we're going to have to use a scale factor or the idea of a constant variation to solve these. But here's the problem. It says reds vary directly as blues squared and inversely as greens. So that's going to give our first formula. We have to remember direct and inverse variation. So when they tell us that reds, separate this, when they tell us reds vary directly as blues, what they're saying is the variation of reds to blues, and it's not just blues, it says reds vary directly as blues squared. So I'm saying that the ratio of reds, the ratio is reds to blues squared, right? So that's the ratio. Now, when they say that reds varied inversely as greens, that means reds is going to be in the numerator and greens will be in the denominator. So it says reds vary directly as blues and inversely, directly as blues squared and inversely as the number of greens. Then they give us an example of this. They tell us that we can go ahead and write this as an equation. They tell us that when there were 80 reds, so reds, there were 4 blues, and that's going to be blues squared, so 4 squared, and there were 2 greens. So that's the variation. Oh, wow, I'm terrible. I just realized I was off the paper the whole time. So this is our ratio that we've been working with. Reds varies directly as blues squared, inversely as greens. And the problem tells us that when the number of reds was 80 and the number of blues was 2, the number of green was 4, the number of greens is 2. So number of blues squared, right? And then inversely is number of greens. Now the problem is if you look at this equation, 16, 4 squared is 16, 16 divided by 2 is 8. 8 does not equal 80. That means we're missing something, and that's their scale factor, or what they refer to as K, the constant. So there's a scale factor from this red to blue and green ratio. And we just have to figure out what that is. We can do it by solving this example. So 4 squared is going to give us 16. 16 divided by 2 equals 8. So what we have here is 80 equals 8 times the scale factor of K. If I finish solving for K, I can quickly learn that the scale factor is equal to 10. And then I set up this exact same equation. So the actual equation we set up is that reds varies directly as blue squared, inversely as green, times a scale factor of K. And that's what we did here. So then let's plug in the next scenario in the problem. They tell us they want to find out how many reds there are when there are 8 blues and 10 greens. And then we have to add in our scale factor of K, which we just learned is also 10. So now finding out this number becomes very easy. We just have to simplify this problem. So 8 times 8 gives me 64 over 10. So 64 over 10 times whole number 10. We'll just put 10 over 1. I can cross cancel these. 10 and 10, 1 and 1. The answer becomes 64. R is equal to 64. And that's our advanced ratio word problem. All right. So remember, set up your ratio. Direct variation means that they're equal to each other. Inverse variation means that it's going to be in the denominator, or not in the same plane of the fraction. And then there's a constant there. There's always an invisible constant. The first thing you have to do is find out what the constant is, fill that into your equation, find your unknown. We'll do a part 2 for lesson 18 because there are 2 other types of advanced word problems that we just need to be ready for. So this is lesson 18 part A, and you should be able to find part B on Moodle.